The final demo presentation for the day is to demonstrate an end-to-end analysis with EMDS. By leveraging the power of the various EMDS engines, we will be able to do a comprehensive end-to-end analysis of a target area, the Chewaucan Watershed. The schedule is as follows: introduction of the Chewaucan Watershed and goals of the analysis, and demonstration of creating an EMDS project. We will then do an EMDS methodology and NetWeaver integration and do a demo to create the assessment and perform the initial analysis to determine the current state. We will view the results inside of the Hotlink Manager. We will then look at the CDP integration and do a demo to create a task to determine the restoration priority of watersheds and stream reaches. Finally, we will do an LPA integration talk and a demo to create a portfolio to determine which actions can be accomplished within a specific budget. The Chewaucan Watershed is located in western Oregon and Washington, encompassing the Fremont-Winema National Forest. This area is dominated by ponderosa pine, lodgepole pine, and white fir, with dozens of smaller streams and rivers. The goal of our analysis is to determine the current status of the watershed and what action can achieve the following objectives: halt the habitat degradation, maintain ecosystems in good condition, and aid recovery of freshwater habitats of at-risk fish populations. As we look at our map inside of ArcMap, we notice that there are several layers which make up our Chewaucan watershed. For our purposes, there are two primary layers needed for analysis that we are performing: the basin boundaries and the sub-watersheds. To create a new EMDS project, we click here on the Create New EMDS Project button. This will bring up the Create Project wizard, which will give it a name, Chewaucan. A new project is created and is then ready to perform an analysis. Now we will talk about the EMDS methodology, which is a basic workflow that helps guide the user to perform an analysis. The first step, as we have seen, is to create a project. We will then specify a spatial extent and the data layers that would be part of the assessment. From there, one or more tasks are used to perform an evaluation or analysis. An assessment is the step where we specify the spatial extent and data layers. After you create a new project, the Create New Assessment wizard is brought up. Please note, you can also bring it up by right-clicking on an existing assessment, and a menu will pop up where you can start the wizard. The assessment name is Watershed 1. Type now. And we will add the basin boundary layer as a type layer, and the target layer as sub-watersheds. We need to have at least one layer as a target, since that will control the spatial selection. We will then click Next. We will select all the watersheds, and then click Next. And then when this is done, we will click Finish to create the actual assessment. A single new overlay layer is created that will be the base data for all the analysis for the assessment. For our Chewaucan example, we first need to determine the current status of the watershed system. NetWeaver is a great tool to answer questions about the state of the system. A NetWeaver knowledge base was created and has items such as the reach condition, and upland condition. Both of these are built into the NetWeaver knowledge base. Okay, so what we need to do is for this knowledge base, we will need to link it back to the spatial overlay layer we just created. So now back in ArcMap, we will right click on Watershed 1 and select Add New Analysis. We will select NetWeaver as a task. We will call this task current state. And click Next. Select the knowledge base file. Then we will click Next. And we will then need to select the topics we wish to evaluate. In this case, we will select all topics, which is under Watershed Evaluation. We hit Next. We can then map the overlay fields to the knowledge base and hit Finish. Please note that everything was auto-mapped, but you can manually do it too. So to view the results, we need to look at Hot Lake Manager. So we will right click on current state and select View NetWeaver Results. We will look at the watershed condition and we can see the map with the results. If we click on a watershed on the map, the NetWeaver model on the right hand side will display how it came up with the specific results. We will also add upland conditions and then click Add Hot Lake Topics to Map Project Display. Okay. The next step is to create a decision model using CDP to determine the priority for the restoration of the watersheds. This is our CDP model that was created for this. In ArcMap, we'll right-click on Current State and select Create New Task. In this case, we will leverage CDP. Inside this wizard, we will enter in a prioritization name of Restoration Priority. And then we click Next. We will then select the appropriate CDP model. We will then map the results from the NetWeaver analysis and overlay to the lowest criteria on the CDP model. Please note that you can double-click to move items from the database field to the current field in the data mapping, or you can use the arrows. And the final thing that we need to specify, because this is a CDP project, is a display field name. In our case, this would be subname, which would be the sub watershed name. Click next, 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 and then we can click finish. And this will then go off and run the prioritization. Unlike NetWeaver, the CDP tasks will always add the prioritization layer onto the map. However, if we want to see additional information, we will right-click on Restoration Priority 1 and select CDP results. Okay, here we can see the input table, the lowest criteria priority values that were calculated, calculations with the graph, what are the contributions, and the sensitivity analysis, and the trade-off analysis. That completes that demonstration. So our next evaluation is to look at which of the actions can actually be done with the budgeted amount. Leveraging VisiRoll, a model was created so we could sort and separate out the restoration activities to a portfolio. Inside ArcMap, we right-click Restoration Priorities and select Create New Task. Under Actions, we will select Action Portfolios. Okay, we'll give it a name, Port 1 for our first portfolio. A unique field name, and then we will specify what is the benefits column, which in our case would just be CD2, the unit, which we would do dollars, the cost field name, which would be a modifier of the road density, and we do dollars there, and then we specify a maximum budget that we'll cut off, and we'll say it's $18 million, and we hit next. This screen will allow us to specify if there were budget silos or multiple budgeting accounts that this could come out of. And since we're going to keep this a pretty simple initial demonstration of portfolios, we will click next, which will then generate a map with the parties that are in portfolio that are in light color if they're not in portfolio, and in a dark green if they are in the portfolio. This includes our basic end-to-end demo of EMDS. Thank you very much. My name is Stephen Paplinas of Mountain View Business Group, and you can reach me at steve@mountain-viewgroup.com.